It's not working.
Okay. Thank you very much. It's finally time to start. We hope, all of us, me and the judges, we hope you like the problems. Now we'll go through them and try to explain all the solutions. But before that, let me say a bit about the jury this year. I'm Federico, the chief judge, and I tried to have a judge from each country, and in a weak sense, we managed to do that. We just have a judge who is living in Israel, is not from Israel, but we'll try to do even better next year. By the way, let me just call on stage all the judges, because I really believe they deserve a round of applause. So we have Filippo, Andrea, Cesc, Simon, Piotr, Gerard, Giovanni, Pedro, Mike, and Stephanie. Please, everyone should come on the stage. Give them a big round of applause. I did fundamentally no problems for this contest. They are all theirs. Thank you very much. You can go. Amazing. Okay, these are the statistics for the contest. There is nothing particular to say. Maybe just that we were expecting maybe problem H to be somewhat easier and problem K to be much harder. It was for us very much unexpected that problem K was solved very early in the contest. Like someone solved it, I think, in the first half an hour, so congratulations very much to you. Apart from that, you can see that, I mean, people continued to solve stuff during the whole contest, so I guess not many people got bored, which is nice. So, now we will go through all of the problems. Maybe I'll skip, I mean, the first one is mine, but everyone solved it, so there's not much to say. I just want to say that the content of the problem was true. It was amazing to be a chief judge, since I received many good quality problems, and it was very easy to select a problem set. I mean, the problem is, all of you solved it, so there's no reason really to go through the solution. This is the solution, and all of you know it, because all the teams solved it. So now I'll save some time, and I'll give it to the other judges. So, please, Andrea, your stage is yours.
Thank you. Okay, I don't know how this thing works, so hopefully. So let's move on to the next problem, which is problem F, about arrangements. So we're still obviously in the easy area with 89, roughly 60% of the teams who solved it, actually of the submissions, but whatever. And congratulations to temp name who solved it after only 9 minutes. So, well, I press the key. It's not working. Okay. The statement is kind of simple. We basically have n battles, and we have to assign a type to each of them, either red, white, so that some constraints are satisfied, actually. Namely, there are m critics, and each one of them says, well, I want to taste RI battles of red wine and WA battles of white wine, and they should be in a consecutive interval. Can we do that? And if so, we should produce a solution. Now, here there is one quite simple idea, but still not completely trivial, which is the following observation, that if there are too many red wines and white wines among the requests, then the answer is the task is impossible. This means that if we call R max the maximum of the RIs and W max the maximum of the YIs, then we should have necessarily that the sum of these two numbers is less than or equal to n, because if it exceeds n, then we would need more than n battles. So in this case, we should output impossible. Now, if we are in the other case, we can actually produce a solution, so the answer is yes. And in fact, the simple string obtained by juxtaposing R max letters R and the rest is W, so n minus R max, this thing is actually a solution, and it's very easy to see why. Like, well, apart from the math, just look at the picture. If you want to take Ri bottles of red wine and Wi white wines, you take an interval which lies in the middle, and it works. Yeah, and this is the solution. Runtime space complexity is linear. I just want to point out that it was easy to mess up the second part by outputting, for instance, R max red bottles followed by W max white bottles. This is not a solution. I'll leave it to you to understand why. Okay, next one is Joey.
Then we have boundary, which was the third and last of the easier problems, solved by more than half of the teams, I believe. It asks for which values of A can you tile the boundary of a rectangle with A times 1 tiles, either vertical or horizontal. So clearly, for A equal 1, this is always possible, so let's just assume A is greater than 1. Or I should say, this problem was prepared and created by Mike, who is not here. But let's go back to the solution. So for A greater than 1 now, let's look at the 4 corners. So each corner can be tiled in 2 ways, either with a vertical or with a horizontal tile. So there are actually only 16 ways to tile the 4 corners. And now the key idea is that if we fix one of these 16 configurations, we can explicitly enumerate all the possible values of A for which you can finish the tiling of the 4 sides. And this is what we're going to do now. And this is quite easy because if we take one of the 4 sides, we have that A has to be a divisor of either the side length or side length minus 1 or side length minus 2, depending on whether the 2 corners are tiled with horizontal or vertical tiles. So basically, yeah, I guess I already said this. And so basically, we find that A has to be a divisor of 4 numbers, which we can compute. So, a divisor of the GCD. And now we just find all the divisors of the GCD. We put them in a set and return the sorted set. And this can be done in a complexity that goes as the square root of the side lengths, because we can just, to find the divisors, we can just check up to the square root of the number, and that's good. One last note, it is actually possible to optimize and avoid going through all 16 configurations of the ways to tile the corners, but this was not required to get accepted. Okay. I'll leave the ground to Filippo.
Okay, so problem D, ice cream shop. This problem was created by Stephanie and prepared by Pedro. I'm neither of those people, but I'm going to present the solution. So the problem was the following. We have N huts and M ice cream shops all lined up on the beach. And we want to place a new ice cream shop so that the number of people coming to our shop is as high as possible. And people will come to our shop if and only if this shop is closer to them than any other shop on the beach. Now, the idea is that if we consider 2 consecutive ice cream shops in position, say, A and B, and we want to place our shops between those, then we only need to consider huts lying in this interval. And more specifically, if we pick a position S in the interval between A and B, then there's going to be a sub-interval, represented here in red, of length B minus A over 2, which is going to contain exactly the people that are going to come to our new shop. And in fact, it's not hard to see that every such interval, so every interval between A and B of length B minus A over 2, can in fact be obtained by suitably choosing the position S. So instead of deciding where to put the new shop, it's perhaps easier, more convenient, to find the interval of length b minus a over 2, which contains the most people. And so how do we do this? Well, one way is, first of all, we sort the positions of the ice cream in the ice cream shops in increasing order. And we can always assume that the interval we're looking for starts slightly to the left of one of the huts. So we try each hut, and for each hut, we compute the ice cream shop lying immediately to the left and immediately to the right. So in positions A and B, according to the previous slide. And so this gives us the length, which is, again, b minus a over 2. And so now we have the left endpoint, we have the length, and we can compute the number of people lying in this interval using, for instance, prefix sums. There can be some boundary issues which are annoying. The easiest way, perhaps, to deal with them is to just add dummy shops, positions minus infinity and plus infinity. Yes, so this is the solution. It gives an algorithm of time complexity n plus m log m, because we have to sort the ice cream shops, and then everything else can be done linearly. Okay, so this was the solution for problem D. And right, so I'm also going to present the solution of problem E, which was created and prepared by Stephanie, who again is not here. So this problem asked us, so we were given two strings, U and V, composed of characters A, B, and C, and we were asked whether we can obtain one from the other with a series of mutations, where one mutation is either the insertion or deletion of one of the following strings, so AA, BB, CC, ABAB, or BCBC. Now, first of all, we can see that none of the mutations alter the parity of the number of Bs, and this is very clear from the strings. So if the two strings have different parities of number of Bs, then clearly the answer is no. Otherwise, one way to approach this problem is to somehow normalize the strings U and V, so find unique canonical representatives for those strings, and then compare the two canonical representatives. Now, the key idea for solving this problem was that the characters, say, A and B, commute. So wherever we have the substring AB, we can always replace it with BA. And here is a string of, a sequence of mutations which show this. And similarly, the characters B and C commute. And what this tells us, basically, is that we can move the characters B wherever we want, so we can ignore them as soon as we know that the parity of the number of occurrences is the same. So we only focus on letter A's and C's. And again, we can erase pairs of adjacent A and C's. So we do this as much as possible until we end up with two strings of alternating A's and C's. And then it's not hard to convince ourselves that the answer to the original question is yes, if and only if those two reduced alternating strings are exactly the same. So this algorithm can be implemented in time which is quadratic or linear in the number of characters. No optimization was required to fit the time limit. But what's interesting from a mathematical perspective, in case anyone was wondering, this problem is actually an instance of the word problem on Coxeter groups. What I mean by that is that we can think of strings as elements of this group here, the group generated by characters A, B, and C with relations given by the mutations. And the problem is basically asking a version of the word problem. So determining whether two strings actually represent the same element in this group. Now, the word problem is unsolvable for general groups, but this group G is an example of a Coxeter groups for which the word problem is, in fact, solvable. But you didn't need to know any of this to solve the problem. Thank you.
Hey, so the next problem was circular maze, which was a problem for which there was 44 submissions, 22 of which were accepted. And it was first solved by Rob Potts after 1 hour and 7 minutes. So the problem was, given a circular maze, can you solve it? Can you find a path from the center to the outside? So even though the problem looked scary at first sight, it was in fact possible to reduce it to a much more classical problem, which was like solving a maze in a grid. And if you see the rows are the radii and the columns are the angles of the moles, the problem basically boils down to finding a path in a graph. Well, a graph is a grid, and two cells are going to be connected if there is no wall between these two cells. And so because the statement ensured that no walls were overlapping, it could even be possible to build this grid in an efficient way just with a naive algorithm. And that's the reduction. But of course, there was some technical details in this problem, like mainly the fact that because angles are circular, you could go from the left side to the right side of the maze. Also, you had to take care of the fact that we are looking for a path from the bottom row to the top row. So we had to be careful with these two details, with either adding dummy cells or entire rows of cells. So that's the details. Now to solve this question of finding a path in a graph, you could use whichever algorithm to find path in graphs you knew, either BFS, DFS, or even disjoint set data structure. That's it. Thank you.
So problem C had 9 accepted submissions before the freeze, and the first one solved by temp name in the first 2 hours. So the problem was about finding the maximum number of kids that you can see, which when you start at position 0 and you have a given maximum speed. And well, it could be translated at the maximum number of points that you can see in the plane by moving inside a cone from the vertex where you are. So the key observation is that 2 kicks can be monitored, even only if this inequality holds, which means that the space that you travel is less than the velocity times the time. And this can be transformed into 2 inequalities where the left-hand side only involves one of the kicks and the right-hand side only the other one. So if you call x the numbers appearing in the left inequality and y the numbers appearing in the right inequality, you can transform the sequence in the statement into finding the longest sequence of indices such that both the x sequence and the y sequence are non-decreasing. It's maybe clearer to see a geometric interpretation in case the speed is 1, which you can always assume by multiplying the times by the speed. So for example, in this case, the reachable cone from the signal vertex is shown in orange. And if you rotate by 45 degrees the plane, which is equivalent to the change of variables to x and y from before, then it's clear that, you have to exclude all the kicks that are not reachable from the origin. This was the cause of some trouble in the submissions. Then, if you do this rotation, the problem that we have to solve is standard. You just have to find an increasing subsequence in x of maximum length, which is also increasing in y. And the way to solve this is to sort the pairs lexicographically, and so it means in direction x, and in case of tie, the lowest y comes first, and then find the longest increasing subsequence of the y coordinates in the resulting array. And there are several well-known algorithms to compute this, for example, by using a segment tree or by doing binary searches.
Okay, so next most solved problem was problem K, which we were not expecting that, and was solved in 20 minutes. We were not expecting that at all. And okay, so the problem asks us to assign a permutation to the vertices of the tree, so we have the maximum increasing path. So to solve that problem, we first make an observation, is that this is the same as to orient the edges of the tree, and find the maximum oriented path. So first, we want to make some observations. The first is that once we make an optimal orientation, we won't have any path that changes twice the direction. Means any path, not a directed path, but any path. So this is, if we consider a path like that, we can find at least one way to improve the solution. So the first one would be, or we switch the edge AB and all the subtree that is hanging from A, or we invert the edge CD and all the subtree hanging from D. And this can be proved that always increase the number of paths. From that, we can know that there is at least one vertex, which is a crossroad. That means that all the paths going through that vertex will, not through that vertex, but starting or ending at that vertex will be directed. So all the edges will be hanging from that or going to there. So here you have a picture showing more the idea. And once we find this vertex, or we choose this vertex, the solution is just to choose each subtree which orientation we'll have. So in this picture, we have group S, that it's pointing to the vertex B, or group T, that is pointing from vertex B. So this solution, once we have these groups, the solution is computed with the formula. And to maximize this solution, we need to find S and T with values as close as n-1 divided by 2. So one way to do that is we have to solve the next subproblem of the subtrees once we choose the vertex. So we can go and choose any of the vertex. If the vertex is not the centroid, then we have a component that is bigger than half of the vertex. So we just choose this component to be S or T, and the rest of them together is the other group. But if this vertex is the centroid, then we have to do the next subproblem that can be improved and with a standard technique and bit sets, and can be solved in n square root n divided by the size of an integer, which is fast enough. Also, this wasn't needed, but you can prove that you just need to check the centroid, and there will always be an optimal solution with one of the centroids. So.
Hey. So the next problem was antennas. So it was set by myself, but it was prepared by Michal, who cannot be here today. So many thanks to him. So the number of submissions for this problem was 23, and 6 of which were accepted before the freeze. And the first solve was by temp name after 2 hours and 20 minutes. This was another problem where we had to compute a path in a graph. And the graph was, we had antennas which were connected if the distance was smaller than the minimum power of the 2 antennas. And finding the shortest path is something you probably already know how to do with, for example, a breadth first search. That would be nice if we could use this algorithm. But the problem was there might have been too many edges, up to n squared, which was too big for this problem. And so the idea of the problem, of the solution, is that we could, in fact, ignore most of the edges in this graph. Namely, if we already reached a node from somewhere, we don't really care about reaching it again. And so if we split each edge in 2 directed edges, UV and VU, we could, in fact, delete all the edges which are not useful anymore because we already reached some node. And we might have a way to do it this efficiently. So to do this efficiently, let's look at the condition for 2 antennas to be connected. So 2 antenna I and J will be connected if their distance is more than the 2 powers. And in particular, all the antennas to which vertex I is connected lie in the interval centered in I of size 2pi, where pi is the power of I. And so the same is true for all the antennas connected to J. And so we had conditions, sufficient and necessary condition for an antenna to be connected to another one. And if I denote Lj and Rj, the leftmost and rightmost points of these intervals, we could store these endpoints and try to find the next best one. For example, to connect antenna I kind of want to find the closest Lj which could work. And so to find the closest one, we can do this with a data structure called a segment tree, computing a minimum on an interval, the interval being the interval of vertex I. And once we found some new vertex, we don't care about finding it again, so we can delete an element from the segment tree, which with point update is also an operation that can be done. And so this, the entire complexity of this would be n log n because of the query of finding the next neighbors in the BFS, and the space complexity is linear in the number of vertices. Thank you.
So the next problem is the geometry problem, pandemic restrictions. It was solved by only one team before the freeze. And the problem is basically finding the minimum R, which guarantees the existence of a point where you can satisfy some geometric restrictions. So more in detail, given 3 points, you want to find 1 point from which the sum of the distances to the closest point where you can meet from your point and each pair of your friends is smaller than R. The naive strategy would be to maybe do a binary search on this number R, and then you would have to intersect the 3 convex sets, which are the sets of points where you can reach each pair of friends from there. But it's not clear how to intersect these sets efficiently. So instead, what the solution, the official solution does, or what we think we can do is for each point, try to find the minimum R that we need in order to meet each pair of 2 friends from that point. So let me introduce some notation. Given 3 points, which will be your candidate position and the positions of the 2 friends, the Fermat point of these 3 points, or of this triangle, is the unique point P, which minimizes the sum of these 3 distances. And it is a well-known fact that this point is always unique, and we will talk about how to compute it later. Then, given the positions of 2 friends, define f, x and y, define the function f, of these 2 points as the minimum R that you need to visit these 2 friends from the position Z. So the minimum restriction that you will need in order to visit each pair of friends, which are positions A, B, and C, is the maximum of these 3 functions. The main observation of the problem is that the minimum of this restriction over all points is the minimum restriction that you need to solve the problem, and this function f, this function g is convex, because each of the f, x, y functions are convex, and g is the maximum of 3 convex functions. The fact that f is convex is easy to prove, but of course you didn't need to do that. You could just kind of guess it. And we can find the minimum of this convex function using a 2-dimensional ternary search if we know how to compute these Fermat's points efficiently. So there are several ways. There's a more geometric approach, which is constructing this Napoleon triangle, or using an explicit formula, and well, there are many others. Or you could also get accepted by doing another 2-dimensional ternary search, because there was enough time limit. And be careful that if you use the geometric approach, it only works for triangles whose angles are all less than 120 degrees. If there's an angle where a vertex with such an angle, this vertex is the Fermat point of the triangle. And yeah, the complexity it's quadratic or quartic on the logarithm of the precision, depending on the solution that you do.
Okay, next and second to last problem is problem B, drawing photo. First of all, I want to thank Filippo Baroni for preparing it. This was challenging for many teams, with only one accepted submission pre-freeze, which was from Tau++, so congratulations to them. Now, this problem was set in a square n by n matrix of integers, and it has to count something. This quantity is the number of rectangles, such that if you connect with 2 segments, the 2 smallest vertices and the 2 largest vertices, then these segments do not cross. And this is actually quite challenging. The main idea is to focus on these vertices, special vertices, which we will call intermediates. An intermediate vertex is a vertex which is greater than exactly one of the vertices adjacent to it, of course, given a rectangle. Now, why are we interested in these special vertices? Well, just look at these pictures. The rectangle on the left is a good one, so one that should be counted, while the one on the right is a bad one. And if we draw arrows from the smallest number to the largest number, we see that the rectangle on the left has exactly 2 intermediate vertices, while the one on the right has none. And this holds for actually every good rectangle and for every bad rectangle. So if we count the overall number of intermediate vertices and we divide it by 2, we have our answer. How to do this efficiently? It's not that difficult. If for a fixed I, we call ui the number of integers in its row which are less than I, and vi the number of integers in its column which are less than I, then how many intermediate, let's say intermediate triples does I belong to? Well, it's ui times n minus 1 minus vi plus n minus 1 minus ui times vi. And if this isn't obvious, just I've animated this thing where you can see that if I is 7, the red numbers are the vi's, and the green number is ui, which is just 1. And the number of intermediate triples which have 7 as a middle number are 1, 2, 3, 4, 5, which equals the expression that I've written above. So that's the answer, 1/2 times the sum of these quantities. And how do we compute these quantities? By just sorting the numbers in increasing order and iterating over them. And, well, then it's kind of easy. As n was like 2000, we can sort in n squared log n, but actually we can do it in sharp quadratic time using counting sort. Okay, thank you.
Okay, hi everyone. I'm going to talk about problem round table, which had 0 accepted submissions, or has it? Because we still have 3 submissions which were after the scoreboard was frozen. So we are talking about having n people at a round table, and we can swap them, but we cannot swap 2 people with consecutive numbers, and we need to get a specified arrangement. So the key trick to solve this problem is this. It actually doesn't matter what we do almost. As long as in every time we swap 2 people, the person with the larger number is on the left, and we reach the desired configuration, then the number of steps will always be minimal. So the minimal part of the problem statement was not so important. We just need to find some way to do it. And how are we going to do it? So we'll do the following. We'll form our permutation from smaller numbers to larger ones. So after step number I, people with numbers from 1 to I will be in the correct order, and the rest will be exactly to the right of person I. So I can show in this example, this is a third sample from the problem statement. So initially 1 and 2 are in correct circular order, and we want to put 3 in the right position between 1 and 2. And in order to do it, we take all numbers from 3 to 7 and we move them. So because we cannot move 3 through 2, we cannot swap them, so we have to go the other way. So we start swapping numbers, all those numbers with 1, right? So first we swap 7, then 6, then 5, then 4, then 3. And finally 2, 1, and 3 are now in correct circular order, and we spent 5 operations. Now we need to put 4 in the correct position. In this case, again, before 1, so we need to swap all numbers from 4 to 7 with 2. Then we need to put 5 in the correct position. Then we need to put 6 in the correct position. Here we need to swap these 2 numbers a lot of times to put 6 right after 1. So we'll need 2 times 3 operations to do it like this. And finally, we need to put 7 in the correct position. And total number of moves is 22. So in general, this requires this many steps where di is the distance between the position of number I plus 1 and number I if you only look at the numbers of at most I. And yes, then the answer is this, and we can compute it using some segment tree or Fenwick tree. And how to prove it? The main idea is we can just take this algorithm, it computes this sum, and we can notice that no matter what we do, this number changes by at most 1. And because of this, if all this decreases by 1, then our solution is optimal. And cool thing is here, it looks almost like inversions and permutation, but the answer somehow is cubic and not quadratic. Thank you.
Hi again. Thank you, Nikki. Okay, so we somehow managed to get this far into the competition. There is not that much stuff left, so less room for bugs, errors, and crashes. Will this work? The answer is that it is off, and now it does work. Perfect. Okay, so we are near the end. There is now let's call it the thank you talk, and after this we will jump right into the unveiling of the ranking and awards. So this is the thank you talk. Let's see who we are thanking. The last one, the presentation in the opening, I did at 3 a.m. This one I did like 2 hours ago. I should remember what I put into it. So the first one is our ICPC World Finals Diamond sponsor, Huawei. Please give them a round of applause. I will also give you a little bit of a spoiler. Aside from the medals for the top 14 teams, there will be also prizes from Huawei for all the medalists. So, a round of applause. Okay, then we have JetBrains. How many of you used IntelliJ or CLion today? Quite a sizable chunk. Please give them a round of applause to JetBrains. Okay, then we have Bending Spoons, our local gold sponsor. Please give them a round of applause. Give also one to Jane Street. And the last one for our bronze sponsors, Google Cloud, Sheffield, and Chini. Okay, let's see who else is there to thank. So we want to thank all our guests from the sponsors, from Bending Spoons, from Huawei, from JetBrains. And we also want to give a very big thank you to the previous SWERC organizers, and in particular to Antoine Amarilli, which I think is here in the audience somewhere. Please stand up. I hope we did at least as good as you this year, I hope. And also, I would like to give many thanks from our guests from ICPC, which are Veronica Soboleva, which I don't think is here today, but there sure is Boba Manova. Okay. Then I would also like to thank our media staff, the singers, which are Alessandro D'Amico and Tommaso Galvani, and Francesca Lauria, and also our photographer, Marco Patriarca. Please give them a round of applause. Okay. Then also, I mean, we did not that much, but also the organizers, please. Me, Dario Stuni, Giovanni Agosta, the co-director, Federico Glaudo, the chief judge, Edoardo Morassuto, the chief technical officer, and William Di Luigi, the secretary. Okay. So we have many teams that worked on this work. One of them is the technical staff. They're the one who fixed everything to make this contest as smooth as possible. Please give them a round of applause. We also have all the volunteers, all the one in yellow. Please stand up so they can see you. And also, we had a lot of volunteers from Huawei and JetBrains. Please give also them a round of applause. And also for the contest, for all the problems that you solved or didn't solve, the judges. And also you, the participants and the coaches who came here and competed after these 2 years of COVID. Thank you. So I think we can finally start, and let's start unveiling the ranking. Thank you.
Okay, and finally, it's time to reveal the results of the contest. Like, during the last hour of the contest, the scoreboard is frozen, and now it's time to understand what you've done. So, let me do this carefully. Okay, this is the top of the scoreboard before the freezing time. And now we will go through the whole scoreboard slowly, until everything is frozen. As you see, whatever you see as yellow, it means that it's pending. It's pending. It's something that was sent after the 4th hour of the contest. Whatever you see as green is something that was accepted before the end of the contest. Whatever you see as red, it's something that was not accepted and not tried during the whole contest. And whatever you see as gray, it was not even tried. Okay. Let me see if there's something else I want to explain about this, this interface. Yeah, what we will do, I'll do somewhat quickly through all the teams up until the 14th place, which is the first place which is getting a bronze medal or a medal in general. And we will do like this. We'll go through teams, and if there's a team with a pending submission, we will reveal what's the result of this submission. If this submission gets accepted, then the teams flies high to a new ranking, and we will meet it again when we reach that position. If it's wrong, it will stay where it is, and that's the final ranking of such team. So I believe we can start. What you can see at the very end, like the last row, is the total number of submissions in green, the accepted submissions before the freeze, and the number of pending submissions after the freezing time. So now we can start, and hopefully this will go at a normal velocity, and I'll be able to say the name of all the university. So, first of all, we have just one thing. If I make a mistake and this goes super fast, how can I close it immediately? Sorry? Shift Q, then it stops. Shift Q. Amazing, thank you very much. Okay, so we can start. We have the dream team for University of Aquila, first year participation. They did one problem, congratulations, and I want to emphasize that everyone, in fact, was able to solve one problem. This is the University of Aquila. Yeah, exactly. Then we have Universidade de Beira Interior, still one problem again, a bit faster. And then we have Sorbonne University, with one pending submission or two pending submissions. Maybe the second one is correct. And in fact, it is. We'll see it again. Congratulations. Then we have programmers, l'École d'ingénieurs Littoral Codopal, with two pending submissions. Congratulations. And We don't know DP. University of the Basque Country, 1 pending submission, which is wrong, I'm sorry. But still, congratulations. SWERC Chassé, University of Rennes, no pending submission, sorry. 1 pending submission, maybe it's correct, God only knows. Yes, congratulations. 1 pending submission, last minute of the contest, usually not a good sign, but maybe, not this time, exactly. No pending submission, congratulations to the Universitat Pompeu Fabra and Universidad Autónoma de Madrid, no pending submissions for them. And again, another pending submission last minute, maybe, no problem. Then we have Sorbonne University, no pending submission, congratulations, 2 problems. Then maybe 3 problems here, Universitat Pompeu Fabra. The pending submission is wrong, still 2 problems then. Universitat Coimbra, still 2 problems, no pending submissions, congratulations. University of Verona, 2 pending submissions. The first one, it's wrong, but the second one, it's wrong that, okay, no problem. 2 pending submissions. And then, no pending submission, we have Sorbonne University with 1 pending submission. Maybe the first one with 3? No. Because maybe Université de Paris is the first one with 3 problems. Last minute, not even them. Now we have 3 pending submissions from École Normale Supérieure de Lyon. Last minute, it's wrong. But 15 minutes before the end, it was wrong again. But 25 minutes before the end, it was correct. First 3 problems. Congratulations. Then we have Universidad Politécnica de Valencia, 1 pending submission, 6 minutes before the end. I'm sorry. Université de Montpellier, 1 pending submission, and it's wrong again. No problem. Universidad Rey Juan Carlos, 2 pending submissions. Maybe the first one with 4? No. But maybe with 3? No. No problem. University of the Basque Country, 1 pending submission for them, and it's wrong. I'm sorry. But here we have 4 pending submissions, 1 at the very last minute. This would be amazing. Not really, but also 3, it would be very nice, I guess. No, maybe 2. Yes, you see? Woo! Sapienza White, I'm from Rome, by the way. And there's a submission at the very end of the contest, but it's wrong. No problem. Congratulations, Sapienza. École Normale Supérieure de Paris-Saclay, 2 pending submissions. Wrong, but the other one is correct. Congratulations. Okay, 2 pending submissions for Universidad Rey Juan Carlos. The first one, it's wrong. But the second one, at the very last minute of the contest, the 10th submission is wrong. Maybe expected. Università degli Studi di Genova, 2 pending submissions. The first one is wrong, and at the last minute they have a submission which is wrong. That's okay. University of Haifa, Tofi of the Mountain. Last minute, wrong, but just after the start of the freezing time, wrong again. No problem. Università Politecnica de Valencia, 1 submission which is pending after 13 submissions. That's wrong. That's okay. Congratulations. University of Bologna, congratulations again. Uni Boys, 2 submissions. 3 submissions for INSA de Lyon, no pending submissions for them now. Université de Paris, 2 pending submissions. Maybe the first one with 4, not this time, but maybe the other one is the 4th problem. Yes, congratulations. The first one with 4. Then we have Ca' Foscari University of Venice, 1 pending submission, just after the freezing time, and it's wrong. That's okay. Politecnico di Torino, the second team, Polito 2, 1 pending submission, and it's correct. Congratulations, Polito. Universidad Complutense de Madrid, no, sorry, École Normale Supérieure de Lyon, I think we have already mentioned them, congratulations. Universidad Complutense de Madrid, 1 pending submission, 3 minutes before the end, and it's wrong, that's okay. École Normale Supérieure de Paris-Saclay, no pending submissions, congratulations, 3 problems for them. Sorbonne University, 1 pending submissions, maybe another 4, no, that's okay. Politecnico di Milano, 3 problems, congratulations to them. Politecnico di Milano, where we are, exactly. Telecom Paris, 1 submission, which may be correct, it's not. Here we have Centrale Megastomp, École Centrale de Lyon, 2 pending submissions, maybe they're both correct, not one, but maybe the other. No, not even, that's okay. A very difficult name from University de Montpellier. The first one is wrong, but the second one, at the last minute of the contest, it's wrong. Università degli Studi di Genova, no pending submissions for them, congratulations. Universidad Complutense de Madrid, 3 pending submissions. Maybe we have the first 5. We could still have the first 5. Last submission, last minute, no. But this one, maybe. It's correct, congratulations. Still 4 though. Here we might have the first 5 submissions. La Statale Green, Università degli Studi di Milano, from Milan, First one is wrong. Second one, it's correct. Congratulations. We'll see them again later. INSA de Lyon, 2 pending submissions. The first one, it's wrong, but the second one, maybe it's a bit better. 8 submission, maybe no. That's okay. Universidad de Rey Juan Carlos, maybe a different one from the previous one. This one, 3 minutes before the end is wrong, and 2 minutes before the end, it's wrong again. No problem. École Normale Supérieure de Paris and Ulm, 3 submissions here, and 1 is correct. Congratulations. Saper Lipoped, Télécom de Paris, 1 submission at the very last minute, it's wrong. But 10 minutes before the end, they submitted E, and it was wrong too. Okay. Università degli Studi di Torino, at 2 minutes before the end, it's wrong. Congratulations, by the way. Università de Murcia, last minute of the contest, they are submitting one solution, it's wrong, but they're submitting another one a bit before, and maybe it's wrong too. University of Haifa, they have 2 pending submissions, and the first one is correct. Congratulations. Still 4 problems though. University of Coimbra, 2 pending submissions. The first one, it's correct. Congratulations. Here we might see 5 submissions. INSA de Lyon, last minute of the contest. Oh, that's wrong. No problem. And 3 minutes before the end of the contest. That's wrong too. Congratulations, INSA de Lyon. Università di Trento. Congratulations, and maybe, no, okay, that's okay. University of Padua, 2 pending submissions. The last one, last minute of the contest, it's wrong. But the other one, just after the beginning of the freezing time, it's correct. Congratulations. Politecnico di Torino, last minute of the contest, we have a submission, 19 submission on the same problem. 5th submission on the same problem here, but that's correct. Congratulations, unexpected. Here we have 2 submissions. Università di Trento, the first one is wrong, and the second one, just after the beginning of the freezing time, it's correct. Congratulations, University of Trento. So here we have Università di Trento again, a different one though, and it's correct. Here we might have 5 problems though. École Centrale de Lyon, 2 submissions. The first one, it's wrong, and the second one, maybe, it's wrong again. No problem. Congratulations, École Centrale de Lyon. Università di Paris, no submission, is the first one with 4 problems. Congratulations, University of Paris. Same thing for Politecnico di Torino, and same things too for Universidad Complutense de Madrid. University of Haifa, maybe we have the first 5 problems. Yes, congratulations, University of Haifa, first 5 problems for you. Then we have La Statale Green, Università degli Studi di Milano, last minute of the contest, and it's wrong. Congratulations in any case. École Normale Supérieure de Paris, 4 problems for them, and congratulations. No pending submission. University of Coimbra, 1 pending submission, and it's wrong. That's okay. Difficult name, Istituto Superiore Tecnico, 7 minutes before the end of the contest. Congratulations, 5 problems for you too. Then we have Università di Roma La Sapienza with 4 problems and no pending submissions. Congratulations. Politecnico di Torino, again, 4 pending submissions, and I don't know why this is not scrolling anymore. I think this might become an issue. 1 submission last minute, not happening. I don't know the ranking by heart.
So we do the default thing, retry. And now we have to go through everything. Again. Oh, that's too fast. Hold on. Notice that it's impossible to pause it. No. Hold on. Yeah, I know. go.
Okay.
Normal speed now.
Normal speed, okay. Normal speed, it's a big thing, but... University of Haifa. Okay, we already know this result. It's just for me to find the right pace so that I don't have to explode. Okay, so hard name, Instituto Superior Tecnico, one submission 7 minutes before the end of the contest, and it's correct. Okay, we are almost where we were before. Sapienza of Rome, no submissions for them, four problems, congratulations. Same thing for Politecnico di Torino, 4 submissions for them. École Normale Paris-Saclay, 1 submission at the very end of the contest, last minute, and maybe, it's wrong, no problem. Maybe we already knew this, I don't remember. Polycotomy, Polytech Paris-Saclay, 1 submission, which may be true, may be correct, but it's not. Still 4 problems for them. University of Trento, 4 problems and no more pending submissions, congratulations to them. And here we have Politecnico di Milano, which is hosting us, and they have 1 pending submission 3 minutes before the end of the contest, which is, it's wrong. Congratulations, by the way, thank you Politecnico. Then we have Università di Trento with 1 pending submission at the very end of the contest. Is it correct? It's not, no problem. Dominator trees, University of Padova, they don't have pending submissions, so 4 problems for them. Then we have eccentric people from Lausanne, École Polytechnique Fédérale de Lausanne, with 2 pending submissions. They could be the first with 6. 1 minute before the end of the contest, and it's wrong. But the other one, first submission on a problem, last problem L, circular maze, it's correct. Congratulations. Still 5 problems. École Normale Supérieure de Lyon, with problem E, 1 submission, 4 submission actually, and the pending submission, last one is correct. Congratulations. University of Bologna, with 1 pending submission, which could be their 5th, only 1 on the last problem. Is it correct? It's not, no problem. Okay, Università Autónoma de Madrid, 4 problems already, 1 submission on problem D, which was ice cream shop. Congratulations, 5 problems for them. Gali twice, with 2 more pending submissions. The first one is on problem E, evolution of Weasel, I believe, and it was correct. Congratulations, and they still have 1 more. Grinta and Sta Paris. They have 2 pending submissions, so this might be 6 problems actually. Is it? The first one on problem E again, which was solved a lot during the freezing time, but not by them. And also the same is true for problem L. Problem E and problem L were the best ones during the freezing time. Congratulations, 5 problems for them. Then we have Sleeping Jimmy, Central Supelec, again with E and L, who were the favorite during the freezing time. Is it correct, the one on E? 13 minutes before the end, it's correct, congratulations. This might be 6 problems again. Then we have University of Haifa, top of the mountain, they have 5 problems. No, I'm sorry, it's Istituto Superior Tecnico, 5 problems again, congratulations. I believe you are the first one with 5 problems, congratulations. And then we have University of Haifa, they have 5 problems, and in fact, they also are the first one, maybe, yes, I don't know if I have to push something, yes. They are the first one solving problem A. So a big round of applause for the first solve. Awesome. Okay, so now we can go on. We have rated C++, which may be, very likely at least, looking at their submissions, the first team with 6 problems. Up to now, everyone had 5 problems. And let's see if they are, in fact, the first ones, well, not maybe the first ones we encounter with 6 problems. Are they? First problem C, and it was considered very hard. That's wrong. But maybe problem L, that was one of the favorite ones during the freezing time, circular maze, it was correct. Congratulations, the first one with 6 problems. Then we have Universidad Autónoma de Madrid with 5 problems. Congratulations very much. And then we have École Normale Supérieure de Lyon with 5 problems, maybe 6. Do they have 6 in fact? Problem L, circular maze again, which is about the mazes you can find on journals for old people, I guess. It's correct. Congratulations. Then we have École Polytechnique Fédérale de Lausanne with 5 problems and no pending submissions. Congratulations to l'École Polytechnique Fédérale de Lausanne, EPFL. Then we have, in the exact same situation, I'd say, maybe with a slightly better penalty time, Ensta Paris, with 5 submissions, and 5 correct, in fact. Congratulations to Ensta Paris. Then we have Universidad de Murcia, which in fact has 1 submission on L, 6 minutes before the end of the contest. Was this a moment of joy for them? Yes, congratulations. Then we have University of Pisa. I have studied, in fact, in University of Pisa. Were they able to solve problem H after 14 tries? Maybe. Yes, congratulations to University of Pisa. Then we have Sleeping James, Central Supelec. Last problem, problem L, circular maze. It is maybe correct. Congratulations. And then we have ETH Zurich. I am currently, in fact, in ETH Zurich. So let's see if they were able to solve problem L 1 minute before the end. Was this a good moment for them or not? It was not. That's not a problem. I hope you had fun in any case. Telecom Paris. Still last problem. Circular maze, problem L. But a lot of time before the end of the contest, but it's wrong in any case. Then we have École Normale Supérieure de Lyon. Only 1 submission on problem C, which was considered very difficult. Were they able to solve it, in fact? No, they were not. Congratulations in any case. Università di Roma La Sapienza. I think another team we had already met. 2 minutes before the end of the contest, and it's wrong. Congratulations, by the way. 5 problems for them. Politecnico di Milano. Maybe do they have 6 problems, the host of this contest? Do they? They do. No, they don't. Sorry. I was wrong. Congratulations in any case. Università di Studi di Milano, still a university in Milan. They have 2 pending submissions. If the first one on C is correct, congratulations. I think this is the first submission we see on problem C. Then we have Technion Israel Institute of Technology, 2 pending submissions. The first one on problem C, which was a referee match, I think, or Il Derby della Madonnina, sorry. And then we have on problem I, antennas, 2 submissions, both are wrong, no problem. Okay, now we have no more pending submission for some time. Arbor Space University, congratulations to Arbor Space. We'll hear the name Arbor Space University again later. Facoltà di Ingegneria di Università do Porto, not pronounced like this maybe. Congratulations, by the way, 6 problems for you. You are the first one with 6 problems. University of Pisa, again, 6 problems, congratulations. Congratulations. A big round of applause for all those with 6 problems and no more pending submissions. Università de Murcia. Università de Murcia, and also Sleeping Jimmy's Central Supelec. And then we have Università degli Studi di Milano with 1 more pending submission. Could they be the first one with 7 problems? Are they? No, they're not. That's okay. Congratulations, Università degli Studi di Milano. Not last place. The name fits. École Polytechnique Fédérale de Lausanne, EPFL, are they solving the last problem? Yes, first one with 7 problems, congratulations. Then we have Scuola Normale Superiore, where I've studied for my bachelor and my master, Carovana Fighters. Were they able to solve C 2 minutes before the end of the contest at the 7th try? No, they were not, congratulations in any case. UPC 1, maybe the strongest team of UPC. Problem C, were they able to solve it? Yes, congratulations to UPC. Universidade do Porto, they have 1 pending submission, they are going for 7 problems, and they have 11 submissions on this problem. This was a struggle. Was a won struggle? It was not. Congratulations in any case. Then we have another team from ETH Zurich, I believe, with 3 pending submissions in the freezing time. The first one is on C. Is it correct? It's not. But maybe at the very last minute they were able to solve E, maybe. Were they? No. But 3 minutes before the end of the contest, maybe they were able to solve H. Pandemic restriction, I believe. No, no problem. Congratulations very much to ETH Zurich. University of Bologna, we are going close to the medals. 8 minutes before the contest, they are going for 7. It's wrong. Congratulations in any case. Then we have UPC 3, another team from UPC. 1 submission, is it correct on C? First try. Yes, congratulations to UPC. Okay, Outlaws, 1 pending submission, is it correct? And they are going for 7 too? It's correct, congratulations also to Outlaws. Here we have EP Fang, École Polytechnique, with 2 pending submissions. The first one is on G, 10 minutes more or less before the end of the contest, 2nd try of the problem. Is it correct? Yes, very much congratulations to EP Funk École Polytechnique. Anyway, congratulations to University de Lorraine, and congratulations also to École Polytechnique Fédérale de Lausanne. Still the first one with 7 problems. And now I believe the interface should stop, maybe. Why it's not stopping? Congratulations to UPC. I'm going to quit it if it doesn't stop. École Polytechnique again. EP Funk, now no, it's not stopped, but maybe it's still okay. It's wrong. Now it should really stop. Yes. Okay. I have just one doubt for the technical people. But yes, just one moment. Okay, so now we start, and we are in fact in the positions which are awarded medals. In particular, we are giving 8 bronze medals, 4 silver medals, and 2 gold medals. For this, we will have different people from the organization giving the medal, and some people from Huawei giving prizes to the winners. So let's start, and I will call one by one all the teams getting a medal, and we will reveal the scoreboard much slower now, because we have also to take photos and award prizes. So first of all, we have École Polytechnique, who is the first bronze medal of this contest. So a big round of applause for them. And I ask them, please, to come on stage. And I also ask to Noemi Gambirasio, one of the volunteers who helped us a lot in this organization, to award the medal. And I ask to Chandon Hua and Yan Wenxin, who are respectively Director of European Research Institute Huawei and Vice Director of Huawei Milan Research Center, to come on stage to give the prizes. Please, everyone, come on stage, and congratulations to this team. And please stay at the center of the stage until someone will come and give you everything. In the meanwhile, I wanted to give you my congratulations for being the first one solving problem G, which we consider to be a very hard problem, so congratulations very much for that choice. Please go on. Okay, now also take the prizes from away, and one of the two, either Chandon Hua or Yan Wenxin, should give the prize, please. Or both. Thank you very much. And also, please take a photo with them. Yes, please. A big round of applause. Thank you very much. So, we proceed. Now we don't have anything pending for UPC3. I mean, this is the third team of a university, and it's already in medal zone. Super congratulations to UPC for this. And I invite on stage UPC3, Università Politecnica de Catalunya. Please, a big round of applause for them, who are getting a bronze medal. And this is not working. Yes, please, come on stage. And I asked to the singer Alessandra D'Amico, who sang for us during the opening ceremony, to come on stage and award the prize. Congratulations. Please stay at the center and give the medals. And I kindly ask to the two people from Huawei, Chandon Hua and Yan Wenxin, if they can stay on stage. like the whole time, because this is faster maybe if you are already here. Yes, thank you. So that you can give the prizes and then we can take only one photo altogether. Si è spento il microfono. Okay. Yes, also for the prizes for Huawei, please give them now and then we take a photo all together. Both the person who awarded the medals. Do you have the prizes? Like, no problem. Awesome. And now the prizes from Huawei. Amazing. Congratulations, UBC. Okay, still no pending submission for the Istituto Superior Tecnico. They have 7 problems again, and I invite them on stage. Congratulations and a big round of applause for Outlaws, bronze medal winners. And this time I call Tobias Werth, one of the technical people who helped us do everything, I would say, to give them the medals. And again, I asked to the Huawei. Yeah, amazing, perfect. Please, those who are awarded at the center of the stage. Amazing. Do you want to say something? They don't want to say anything. We do have all the medals. We do have all the medals, maybe. Thank you very much. Okay, now we start to have some more pending submissions, so we might start to see the first teams with 8 problems. In fact, we'll see if ETH Zurich, methodical, has managed to solve at least one of the 2 problems they tried during the freezing time. They have 2 attempts on problem I and 5 attempts on problem L. Problem L, which was circular maze, was solved in fact a lot during the freezing time. Regarding problem I, it was considered a bit harder, but still we saw some solutions both during the freezing time and during the contest itself. Let's see how it went for them. Now it will be slower. Were they able to solve I? Yes, first 8 problems for them. Then we have École Normale Supérieure de Paris. They have already 7 problems and they attempted only 1. And it's 4 minutes before the end of the contest and they have 4 tries. Usually this is not a good sign, but maybe not for them. Let's find out. Yes, congratulations to them. Okay, now we have another team by UPC, UPC2. They have 1 pending submission. We have already met them. Were they able to solve also this other problem? Problem C, which will solve quite a bit, as we can see from the scoreboard. Was it? Yes, congratulations to them. There's a lot of solutions, as you can see. And now we have 3 pending submissions from robots. I mean, 3 pending submissions. If they are all correct, that would be amazing for them. Let's find out if it is. Problem C. They have 6 tries. Is one of them correct? Yes, congratulations to them. And so now it's time to give an award to UPC1, Universitat Politècnica de Catalunya. They have 8 problems and no pending submissions, and they are the first team with 8 problems. Congratulations very much to UPC. Please, come on stage. And I invite the judge Piotr Mitryshev on the stage, please, to award the medal. Please, those who have to receive the award at the center of the stage, and the medal should come now. Amazing. Thank you very much. Okay, let's go on. We have University of Padova, which I believe it's the first medalist who's from Italy. They have 8 problems again, and they are the first one in the top 10. So a big round of applause for University of Padova. Congratulations. Yes. And I'm calling on stage Nikki Gerritsen to give the medal to them. Nikki is one of the technical people who, again, made all of this possible, in fact. And now, please, the medals. Thank you, and congratulations again. Okay, once again, we don't have any pending submission from École Normale Supérieure de Paris. They have 8 problems and a slightly minor penalty time for them. So 8 problems and a big round of applause for them. I invite them on stage. Please come. Ensul 3, École Normale Supérieure de Paris. And to award them the medals, I call on stage Andrea Ciprietti, one of the judges. And the medals can enter now. Okay, thanks again. Okay, now we have the last 2 bronze medals, and I believe that if ETH Zurich is able to solve problem L, circular maze, which was in fact solved a lot during the freeze, maybe they are one of the lucky ones, they would be able to get even a better medal than bronze. So let's find out if it was a good day for ETH Zurich Methodical. They have 5 submissions on that problem, which is usually not a good sign. but maybe that's a good sign for them. Yes, and they go in third positions. Congratulations to ETH Zurich. So we have at the next place UPC 2, Università Politecnica de Catalunya, and that's already, I believe, the third or the second team we are awarding a medal from UPC. So congratulations to UPC 2 for solving 8 problems. Please come on stage, and I call the Chief Technical Officer Eduardo on stage. Please, a big round of applause both to the team and to Eduardo himself. And the medals? Thank you. Okay, now there is another important moment, because once again, if we are awarding the last bronze medal, and it's very much unclear who is going to get it. Why? Because if École Polytechnique is solving the problem that they sent at the very last minute, K, then the award might go to robots, but they have 2 pending submissions. And then there is Tel Aviv, they have 2 pending submissions, 3 pending submissions. And then we have Methodical, who is currently third, who might get, in fact, a bronze medal. It really depends on what's happening now. So let's find out together. It's the turn of École Polytechnique et P Orange. At the very last minute of the contest, they decided to send problem K. Were they able to solve it? Let's find out. No, they were not. Congratulations in any case. Please, come on stage. This is the last bronze medal. Please, at the center of the stage. And the medals. Okay, this was the last bronze medal. And now we enter among the first 6 teams. We are awarding 4 silver medals and 2 gold medals. And even though we have absolutely no idea of how many teams will go to the ICPC finals, it's pretty clear that those who are going are among these 6 teams. We don't know how many, but here you are playing for 2 different things. You are playing both for being the absolute winner, you are playing to get a gold medal instead of a silver medal, which is already a very good medal, and you're also playing for the ICPC finals. So, and as you can see, we have 6 teams, and fundamentally all of them but ETH, they have pending submissions, and the majority of them, they have at least 2 pending submissions. So this ranking may change quite a bit. Let's find out how it evolved, and I hope that the ranking will not go too fast. Let's find out. So we have, and I want to emphasize also another thing. We have 2 teams from Arbor Space, and 2 teams from Tel Aviv University. So congratulations to these 2 universities for being able to bring not 1 team, but 2 very strong teams to this competition. You are really improving the competition doing this. And congratulations, I guess, to the coaches for that, because that's amazing. Congratulations. Okay. Congratulations to the coaches, please. Okay, let's find out what happened. We have Robots, which is one of the 2 teams from Arbor Space University. They have 2 submissions, one on H, which was a problem called pandemic restriction, let's say about geometry, as you know from the solutions explanations. And there was also problem I, which was antennas. It was kind of a data structure problem. Let's find out how it went for them. So we have Robots that they are submitting a solution to problem H just after the freezing time. Is it correct for them? Just one? Yes, and they go in first place. Congratulations. Then we have Tel Aviv University with 2 submissions. But one of them is the very last minute of the contest, which is usually not a very good sign. Let's find out if it was good for them. This will take some time. Is it correct? No, that's okay, but they have another try. Also solving the other one, I believe, would be enough to move them to the first position. Is it? Yes, congratulations to Tel Aviv University. Then we still have pending submissions, and we still cannot tell with the next one. We have Tau++, with a nice name, I guess, Tel Aviv University, and they have 3 pending submissions, none of them at the very last minute. But they have 7 submissions of problem C. I think they were struggling quite a bit with the time limit. Were they? Yes, congratulations to them. And therefore, given the huge amount of pending submissions, it turned out that ETH Zurich is 6th, and it's the first silver medal. Congratulations, and a big round of applause to ETH Zurich, who doesn't, and they don't have anymore any pending submission. And I'd like to call on stage ETH Zurich, and I'd like also to call on stage Giovanni Agosta, who was at the same time one of the directors for SWERC and the representative for Politecnico of Milano. So please, a big round of applause, both for him and for the team. And also, I'd like to invite from Huawei, Renato Lombardi, who is the director of Huawei Research Center. He will give the prizes from Huawei to all the silver and all the gold medals. Thank you very much. Okay, the photo is taken. I kindly ask to the director of the research center in Milan to stay on the stage. Oh, amazing. Okay, so we can go on. Once again, we have, I think, all teams but Tel Aviv University team name, who is currently second, so would get a gold medal currently. Everyone else has at least 1 pending submission. So it's still, everything is still open. So now we have École Normale Supérieure de Paris, which is traditionally a very strong team here in SWERC. Let's find out if this was a good year for them and they were able to solve, in fact, 10 problems or not. École Normale Supérieure de Paris, they have 1 submission on problem I, which was this problem about data structures. 14 minutes before the end of the contest. It could very well be. Let's find out. No, it was not. Thank you in any case, and congratulations. A big round of applause for them. I kindly ask them to come on stage, and let me also mention the fact that they were the first one able to solve E and problem H. E was evolution of Wiesel, these problems about strings or group theory, depending if you're studying mathematics, and H, which was again somewhat of a mathy problem. Maybe they're studying mathematics, I don't know. And this time, the medal is awarded by Renato Lombardi, who is also giving the prizes from Huawei. You have also a co-coach. If you have 5 prizes, then 5, otherwise 4 is fine. Allora Sandro. Avete 5 medaglie. And also the photo. Please, also in the photo. Yes. Thank you very much. Okay. So, same situation as above, and now we have a team with a strange name, Kempiro Cossack, and they have 2 submissions. Both of them are incredibly close to the end of the contest. Usually, this is not a good sign, but they have 2, so maybe it's because they solved 1. Let's find out. So this is one of the 2 teams in Arbor Space competing, and if they solve 1, I believe they have very good chances of getting a gold medal. Are they? No, not this one at least, but maybe the other. So they have 1 submission for problem H, pandemic restriction, at the very last minute of the contest. Were they able to solve it? No. Congratulations in any case. Please come on stage, Kerpir Kosak from Arbor Space University. And I want to mention that they solved problem K something like 23 minutes into the contest, which was very, very unexpected for us, for the judges. We were not expecting this problem to have many solutions, and in fact it didn't have many solutions, and we were not expecting this problem to be solved so quickly. So congratulations for that. Please, at the center of the stage. And I call on stage Andrei Ivanov from JetBrains to give the medals. Please. Okay, thank you very much. And now we are at the top 3 of the contest. There is 1 team with no pending submissions, Tel Aviv University. There's 1 team, Arbor Space University, with 1 pending submission. And there is another Tel Aviv University, Tau++, with 2 pending submissions. As you can tell, fundamentally, everything is still to be decided, and in particular, if Tau++ is able to solve at least one of the 2 problems which are missing, then they will immediately get a gold medal, for sure. And then Tel Aviv will get the other one. So it's the same university competing with itself. And otherwise, they're getting the silver medal. So the first 2 are getting a gold medal, and the third one is the last silver medal. Let's find out who is getting it. They submitted problem G, which is considered very, very hard, and it was solved only by 1 team up to now. They submitted it at the very beginning of the freezing time. Was it good enough for them, and did they solve? No, but who knows? maybe they were able to solve problem I a bit more into the freezing time. They have just 2 tries. Yes, congratulations, and they are the first team with 10 problems. A big round of applause for them. Okay, and then we have our last silver medal, the other team from Tel Aviv University, temp name, with 9 problems. A big round of applause for them, and they're invited to come on stage. And they were also the first one solving 3 different problems, C, F, and I. And I kindly invite Lucas Truppe from Bending Spoons, the sponsor, to come on stage, please. In the meanwhile, I'll mention something about Tel Aviv University. If I'm not mistaken, and I might very well be, they appeared as a strong force in SWERC last year, and it seems they really are. Like last year, if I'm not wrong, they actually won the competition, and this year they have 2 different teams among the top 3. So something happened there, and congratulations to the coaches or whoever is preparing them, or to the students themselves. Congratulations. Thank you very much. Okay. Okay, and now both teams who are remaining, they are from different universities, and there is one with 10 problems, Tau++, and there is one with 9 problems, Raupots. But if you do the computation, it turns out that if Raupots are solving problem I, they are in fact winning SWERC. On the other hand, if they are not solving problem I, they are just second. Still a gold medal, of course, but you know, it's very much different being first or second. So I guess it's time to understand, and I want to emphasize that also the 3rd and the 4th place are Tel Aviv University and Arbor Space. So this was a kind of domination this year. Let's find out who dominated them. We have Arbor Space, Robots, indeed. Who's the winner of SWERC this year? Will they be able to solve I? Yes, a big round of applause. Congratulations. So, still Tau++, an amazing performance. They also have 10 problems, 10 different problems, by the way. And I invite them on stage, please. And they are also the first ones solving some of the problems. Yes, they are the first ones solving B and D, second, and they have solved 10 problems. The first team solving 10 problems. Please on the stage. And I also invite Boba Manova, the ICPC Europe Director, to award the medal. Thank you very much to ICPC in general, and thank you, Boba. A big round of applause. They didn't win, but still they made an amazing performance, so congratulations. Thank you, and I kindly ask to this team to remain on the stage. To remain on the stage. Yes. Amazing. And then, for the final celebration, we have robots from Harvard Space University. They solved 10 problems with a slightly less penalty time, and they are in fact the winner of this year's SWERC, and the first time in Italy, so the current trophy holder for SWERC. A big round of applause for Harvard Space University robots. Woo! Congratulations. And our director, the person who made it possible, yes, the person who made it possible to organize all of this is the one who is going to award all the medals, the gold medals to them. So the stage is to Dario from now.
Congratulations again. Please, another round of applause. We will see you in Dhaka in 2023 in Bangladesh. Thank you. Okay. So, I think that this is the end of SWERC 2021-2022. We hope that you liked it. We hope that you enjoyed it. And yeah, they will go to the World Finals. Yeah, of course. The first team, so the winners, robots, will go to the World Finals in 2023. And it may be possible that maybe another two teams will also go as well. We'll see. So, again, I think this is the end of SWERC 2021-2022, not the end of SWERC, hopefully. And I will just end with thank you all.